Take it away, Jonas.
Thank you very much. So let's start the show. What we're seeing here is from this Monday. This is 5 days ago in NRK, southern Norway, where we went live for the first time. And this is the producer working on their first ever Sofie controlled broadcast. This is the Norwegian broadcaster NRK wanted to switch studios, so we can go further. And it was a successful broadcast. That was the first of 3 that night, and it's been running ever since. So it's a total success. My name is Jonas Hammelström. I'm from SuperFly.tv, and we actually built this system for NRK. So why did NRK choose to build their own automation system? Well, they wanted to move studios and modern automation system. To quote the system owner, we wanted to reduce complexity and establish technological flexibility. So I'm going to give you a very quick overview of the Sofie automation system right now. At the core of every automation system is something that controls everything, right? You talk to the user in the system, you talk to media asset management, video playout, graphics playout, vision mixer, audio mixer, in the NRK case, metadata logging and status monitoring. The UI is run through web browsers, so you can access it from laptops, from desktops, or even mobiles. These are modules we have right now, and in Q4 of this year, we're building camera control, lighting control, recording, transcoding, VSM integration, and prompter. So, looking at the architecture, as you can see, it's very modular. You're not really tied to what kind of vision mixer you have or certain broadcast equipment. It's built to be very flexible, to be able to write new modules and add whatever stuff you have. Something else that's really cool is that it's state-based. That means that you're not really forced to, if a process goes down and it has to be restarted. Normally you have a log of thousands of commands that you actually have to play out to get to the state where you lost the process. State-based means that everything is kept, the state is kept, and if we, for example, restart the video server, that takes 3 seconds. We come back, and you're actually 3 seconds later, you're coming back exactly where it's supposed to be, because the video server will know that I'm supposed to be playing this video right now, and I'm supposed to be at this time code. So it's very resilient. Something that was very important for NRK is continuous deployment. I'm sure we've all had the problem where there's a problem in the system. You call support and they say, yeah, that's fixed. And you're saying, no, I'm seeing this bug. Well, it's fixed in our version, but you're not running that. So very important part for NRK was continuous deployment. I mean, it shouldn't be an afterthought. Just deploy. You can deploy between broadcasts on the same day, right? You should always be able to run the new stuff all the time. Looking at a bit of the architecture, it's built on Node, TypeScript. It's virtualized, running in Docker containers. And this, of course, means that not only can you run it in the cloud, you can run it in your own cloud, you can run it locally, or you can even run it offline, like we're doing here from a laptop. It's based on Linux or Windows, so you can choose whatever you want. So, looking at the user experience, this was the show we were just running. We have nice things like you can actually, in the UI, hover scrub over video clips, you can read the scripts. Something also, since we are running this as a state-based system, it's really easy, and we haven't done it yet. We're probably doing it next week, where you can actually scrub to wherever place in your automation system and just start playing. You don't have to start from the beginning of a video clip or stuff like that and wait for 3 minutes to see what it looks like at the end. You can just scrub wherever you want to go, just start playing. So it's browser-based. We were doing training last week for NRK. And one of the producers was doing training for about an hour. And then we realized in the afternoon, he was actually starting to teach his colleagues how to use this system. So he got about 1 hour of training, testing it, and then he started teaching others. So we're kind of proud of that. This development cycle has been very agile, where we have built new features. And I'm going to just give you a small sample of something that we built. Remember, we went live on Monday. Tuesday night, they said, well, there's a lot of problems with audio levels, so could you do something about that? This is just an example of where we actually built something into EMPS. Audio gain panel. You lower the audio level, and the automation will actually automatically load it. The project timeline has been very aggressive. We started 5th of March, and like I said, we went live on Monday. That's 27 weeks, or actually 24 weeks, because we managed to have 3 weeks of vacation. Just very quickly, the NRK system, they're using EMPS. Omnibus will be going over to TDL in Q4, using Casper CG for both video and graphics layout. ATEM mixer, lava mixers, and all that stuff. So it's really a strategical goal for NRK to use and share open source code. So how much of this is open source? The entire Sofie core is open source. All the libraries we built, and including a lot of modifications to Casper CG. We've added timecode support and other things. We're the largest contributor outside SCT to Casper CG. So finally, that's the URL for a README file on GitHub with all the repos. Everything is open source. Just start using it. And what you're seeing behind there is actually the commit history from March until yesterday, I think. So, thank you very much.
Thanks, Jonas. I have to say that's the most attractive looking commit history I think I've seen for a long time.